Are we starting? Are we starting?
Good day, everyone. Now we are going to start the technical session 6 on severe weather. Actually, we are waiting for the chair of this session. Due to some reason, he is not available yet. So I would request Dr. Mazharul Aziz, Chief Instructor, Agricultural Training Institute, Department of Agricultural Extension, Government of the People's Republic of Bangladesh, to chair the session, and Dr. Mohammad Najmul Ahsan sir as a co-chair of this session until Samsuddin sir arrival. So I would like to request Honorable Chair and Co-Chair to start and conduct the session. Before starting the session, I would like to request Session Chair and Co-Chair to evaluate all presenters according to the prescribed format and send us as soon as possible. Thank you all.
Thank you very much. As you know that we are in technical session 6 on International Conference on Meteorology and Climate Science. I am Dr. Mazharul Aziz. I work for Department of Agricultural Extension, and since 2015, I've been working with World Bank funded project, Agro-Meteorological Information Systems Development Project. It is component C of BWCSRP of the World Bank. We'll be having 4 presentations. That is, those are ICMCS 26, 27, 28, and 29 respectively. So each presenter will get, according to his allocation, time of allocation is 15 minutes. So they will get 12 minutes or 13 minutes for their presentation and 2 minutes for discussion. So let us start the presentation. Dr. Nazmul Hassan, would you like to add something with me so that we can start? Thank you. Nazmul Hassan, please unmute your microphone. Okay.
Okay, sir, thank you. Me, Dr. Mohammad Nazmul Hassan. At present, I am working at the Department of Meteorology as a consultant. In this session, we have 4 presentations, and we can start from now. Sir, you can conduct the session or...
Thank you. Let us start the presentations. First, we'll be having a presentation regarding dynamic implication of jump in rate of lightning prior to tornado genesis. It will be presented by Dr. Prabhat Kumar. May I request Dr. Prabhat Kumar, please start your presentation. Thank you.
Yes. Uh, Thank you very much, Chairman, Co-Chairman, and all the participants. A special thanks to organizers for the conference. I'm very happy to present here my work and my hypothesis on dynamic implications of jump of rate of lightning prior to tornadogenesis. Now, there are so many unanswered questions with respect to tornadoes. First is why most of the strong tornadoes, EF more than 2, are preceded by jump in rate of lightning, CG lightning, cloud to ground lightning. Why most of these positive CG lightnings are there instead of negative lightning, they are mostly positive lightning, and why they spawn secondary vortices also, and why their size is so small. There are so many other questions also, but I'll be addressing these questions with respect to my hypothesis. Lightning jump is recorded by so many observers. This is the on screen. This is by Kane, 1991, and this is the uh, rate of lightning, and this is the timing here, and here is the tornado occurs, and this is a 5 minutes interval average, and this is hourly average. Now you see there is a jump here just before the tornado occurs, and this jump has been validated by so many other workers also, and this is Perez 97. It says 15-20 minutes prior to tornado formation, there is a jump, and also relative decrease in CG activities, cloud to ground activities, in conjunction with the tornado touchdown. Salmon Terre also says mostly they are positive lightning, and Guer, they says 98% tornadoes in the United States have during 3 years period were preceded by CG lightning. Now, this is something very important observations, which shows that uh, there is definitely some connection with CG lightning. And yes, so we will try to observe some of the peculiarities of CG lightning. Positive CG lightning is 5 to 10 minutes, so 5 to 10% only of the entire lightnings, but they are very strong, or 300 kilo amperes in current and about 1000 megawatt in voltage. Negative CG lightnings are much weaker, but they are more in number, 90 to 95% in number. Relatively, they are weaker and about 30 kilo ampere and 300 megawatt. Polarity reversal also has been seen. 6 out of 42 storms studied by so many workers, which are listed here. And they say that after positive lightning, the tornado has formed if they reverse to negative lightning. Model of lightning. This is model of negative lightning here before you. Negative lightning means the negative charge descends from top to bottom, and then positive charge from surface goes up and bridges somewhere in between. And there are so many return strokes, 1, 2, 3, 4, several of them. They go and there is an interval between them. And these return strokes are currents. So these currents, because of Faraday law, creates magnetic field, just like thumb rule. If the thumb is the current, then magnetic field is the fingers around. So magnetic field surrounded, the azimuthal magnetic field close horizontal to ground, the parallel to horizontal ground, and these magnetic fields are associated with each and every return strokes. There is a gap in between of microseconds, and this gap is filled in by Earth magnetic field. So that is why my hypothesis starts here. Earth magnetic field plays an important role in creating a sinusoidal oscillation. This is your because of return stroke, and this is also because of return stroke. In between, there's the Earth magnetic field, and in case Earth magnetic field is opposing the magnetic field created by return stroke, then there's a possibility of oscillation starting. There's another very important property that if you measure magnetic field at any place, then there is a hump notice at fixed time, and then it decays, magnetic field decays further. This is on the screen, this is 1 kilometer measurement, and this is 2 kilometer measurement. This hump is uh, another peculiarity of the magnetic field observations. So having these observations in mind, I have taken computation of Lorentz force created in the corona area where charged particles are there, fluid is artificially conducting because of charges released by lightning. And if J is here, if J is your current and B is a magnetic field, then this is the total average uh, Lorentz force. Uh, that is, the average is taken vertically up to the skin depth. The skin depth is equivalent to uh, boundary layer in the hydrodynamics in magnetohydrodynamics. In magnetohydrodynamics, skin depth is approximately 2 to 6 kilometers height, and this is in my computation. This is only two-dimensional. This is vertically down, and this force is horizontal. If you three-dimensional studies, it will be another y component also will be added to it. This force is most important force, which is causing the convergence and the levitation, that is lifting. Now, in magnetohydrodynamics, there is a rule that from low magnetic pressure, the fluid moves towards a high magnetic pressure. So this is what is happening in the corona field. Corona dimension radially, it is approximately about 50 to 100 meters. So that is the dimension of the tornado also. So that's why tornado is very small. And they go towards high magnetic field, and then once they unite together, then they lift up, obviously. So convergence and lifting. This is purely because of the motion factors. There are other features also. Heating also takes place because lightning is very hot. Lightning is about 30,000 degrees centigrade, you know it. But because air is bad conductor, so entire thing is not percolating. But because of the negative lightning I have computed here, that negative lightning at 1 meter distance, the heating is much less. This is your heating here. Heating is only 0.01 in entire skin depth. And if the positive lighting is there, 1 meter distance, heating in the entire skin depth is about 4 degrees centigrade. That is phenomenal because that provides the buoyancy. So purely on heating considerations, I have computed that it provides positive is very powerful in providing the buoyancy. That's why positive lighting, in my opinion, is observed much more prior to tornado than the negative lighting. But not all lightning are followed by the tornado. This is obviously because if lightning is taking place, this is the your supercell. Is lightning taking place somewhere here, then obviously there's no avail, there's no effect. But in case it is occurring in the region of inflow, this inflow region, somewhere in this region or updraft region, obviously there is effect because lightning will cause further buoyancy, further convergence, and convergence confined to a small space, and that space will give rise to tornado. So this is my hypothesis, and I believe that observationalists will definitely examine it and then test it and prove it that this is coming true. And after this, I have also a hypothesis that what are the region in which there is a possibility of cyclogenesis forming. Now, this is a negative lightning and this is a positive lightning diagrams. And this negative lightning here is that is charges are descend down. So lightning, the current is vertically up from the point of contact from the ground, and therefore with the Faraday law, the magnetic field are like this, whereas in positive lighting, the magnetic field are like this. Now here, geomagnetic field is from left to right on the screen, and therefore in this region, in this A1A, this line, it is opposing. Therefore, cosine oscillations, fluctuations is here in this field, in this region, and therefore there's a possibility of convergence over entire this region. This may be extending from 50 to 100 meters in case of negative lighting, but in case of positive lighting, it's opposite forces are here. This is the fluctuation from this region to this region is taking place. So convergence and levitation is possible in this region. And that is the reason that tornado forms and also many secondaries also form. Many authors have seen secondaries. Bernstein in his book also again. Tornado is here somewhere and many secondaries also form. And all these pictures are secondaries only. Secondaries are forming only because of fluctuations or entire range, which is favorable region for the formation of tornado from cyclogenesis. So this is what my theory is, and I hope that this will be observed in the field also, and then it will be verified too. This is my presentation. Thank you. Any questions? I welcome.
Thank you, Dr. Prabhat, for your nice presentation. May I ask the audience if they have any question? Thank you.
Sir, can I ask a question, sir?
Sure.
Yeah. Sir, it was an amazing presentation, very informative for me. But I want to share something with you that during the study of tornadoes that occurred over Bangladesh, and I studied the lightning scenario associated with the tornado, and it was just surprising that during the tornado, lightning frequency was so low. So did you can explain like what was the reason behind
This is
that?
the right question actually.
Yeah.
What I'm supposed to express to you here, which I have not done in the presentation, lightning is only buttressing it, supporting it, is not the cause of formation of tornadoes. Cause of formation of tornadoes are already synoptic in nature, but they are weak in nature. I have already told you in the beginning that I'm talking of tornadoes which are more than EF2 strength. EF0 and 1 and 2 are possible with the help of synoptic parameters only. But in case you want to strengthen the tornado, which is buttressed with to buoyancy support as well as convergence and levitation support, then you need to have this lightning support too. Positive lighting is most important. Negative lighting also supports, but it will not be supporting from the buoyancy point of view. For convergence, it will be support. So it is not the cause, but it is the supporting factor, which increases the intensity of EF of tornado. Are you satisfied?
Thank you, sir. Yes, sir. Thank you, sir.
We see that another hand is raised. Dr. Mohan Kumar Das.
Yeah, thank you, respected chair. This is a very wonderful talk. Just I have a small query regarding the operational aspect of the tornado. It is seems that still National Meteorological Department not able to give the location specific tornado nowcast. So what is the actually challenge behind that? Because sir already covered many scientific aspect of the tornado. So how it can be resolved? Thank you, sir, for your wonderful talk. Thank you very much.
Challenges with respect to tornado predictions are still there because lightning is not the cause. lightning is supporting factor only. With respect to predictions, one has to definitely measure several other factors, why they are linear, why they are double, triple together, in line together, and why they are suddenly in specific portion, say in US, they are always aligned up from north to south in Colorado region. So all these factors are there and they are not still answered. But I'm talking only the impact of lightning jump. This jump supports the tornado. There have been many studies with respect to tornado predictions from the lightning jump also. But there are cases when lightning jump is not there, tornado is there. So I'm not going in detail of those predictions part. But I'm talking of supporting part because supporting has got many implications, the dynamic implications with respect to convergence and levitation, and buoyancy implications with respect to heating. Something like
Thank you, sir. Thank you very much.
okay.
Thank you, Dr. Prabhat Kumar. If there are no any questions, so we can go for the second presentation. I would like to request Mr. Saurabh De Shubho to let us know the session number. Thank you.
Thank you, sir. With the permission of the Honorable Chair and Co-Chair, I would like to say, due to some technical problem, Tanzina Akram is not present. Instead of Tanzina Akram, Tasnim Sultana Tanha will deliver her presentation on hotspot of extreme climate events in the northwestern part of Bangladesh.
Okay, thank you.
Hello, am I audible?
Yeah,
Hello.
yeah, please start the presentation.
Okay, I'm Tasnim Sultana and I'm a first semester student of Department of Meteorology, University of Dhaka. And before starting, I'd like to thank the chair and co-chair of the session for giving me the floor for this presentation. The topic of my presentation is hotspots of extreme climate events in the northwestern parts of Bangladesh. Extreme climate events are defined as small probability events where the value of weather or climate variable is either higher or lower than a certain upper or lower threshold of the range of the observed data. Bangladesh ranked 7th in the Global Climate Risk Index 2020, having 0.41 losses in per unit GDP and suffered from an estimated loss of 3 billion USD from such events. The frequency and intensity of these extreme climate events have increased significantly in recent decades, but still the knowledge of these events are quite limited. Due to physiographic differences, the impact of extreme climate events can show marked localized variations and form hotspots that are important for devising the climate change adaptation strategies. So it is very important to study these extreme climate events, and one of the most important methods for studying these events is to calculate the extreme climate indices as recommended by World Meteorological Organization. Hence, the objective of my study is to compute the extreme climate indices recommended by World Meteorological Organization's expert team on climate change detection and indices, ETCCDI, in northwestern part of Bangladesh. And secondly, to identify these extreme climate hotspots of the study area using GIS tools from these extreme climate indices values. So methodology, first of all, the selection of study area. I have selected the northwestern part of Bangladesh, which consists of 14 districts and 4 meteorological organizations. This study area has been selected just because it's very much vulnerable to climate change and the extreme climate events. And several studies suggest that extreme climate events representing extreme temperature and rainfall regimes are believed to exacerbate the drought conditions in this part of the study area. Now, the preparation of the data. First of all, the collection of the data. The daily minimum and maximum temperature and rainfall data sets from the year 1968 to 2018 were collected from Bangladesh Meteorological Department, BMD, and the maps which have been used for the comparison with my hotspots were collected from the Bangladesh Agricultural Research Council, BRC. Now, the second step is quality control and the calculation of indices. What is now, the question arises, what is a quality control? While collecting the data from the BMD, sometimes the outliers and redundant data set can be found. For example, sometimes it is seen that the Tmax is bigger than the Tmin, or sometimes the negative values of precipitation can be seen. So this quality control is done using a software called ArcLimedex, and it offers a user interface for our statistical packages and allow the users to carry out quality assessments prior to computing these indices. Now, secondly, the most important part, the calculation of extreme climate indices. Amid the 7 indices, I have used 5 threshold-based indices for temperature and for precipitation, and the data sets of 1968 to 2018 have been used. And for this calculation, a threshold value is needed, and as suggested by World Meteorological Organization, the threshold value for this calculation was the mean value of 30-year data set, and this 30-year range is 1971 to 2000. And for the spatial distribution, I have used 2 GIS tools. One is kriging and another is zonal statistics. The kriging techniques can be used to describe the model of the spatial patterns, whereas the zonal statistics was used to calculate the extreme index values for areas without any weather stations. Now, my results and discussions. The hotspot of the extreme climate indices. This is a visual representation of the hotspots of the extreme temperature indices. 5 indices have been used in this representation, and here we can see the diurnal temperature range, the maximum Tmax, the maximum Tmin, the minimum Tmax, and the minimum Tmin, which are the very basic indices for studying extreme climate events. And here we can see that in my study area, for the first 3 indices, the southern part of the map shows the higher values, whereas the northern part shows the lower values. The red marked zones are defined as the higher areas having the higher extreme temperature indices values, and whereas the blue areas show the lower extreme temperature indices values. And secondly, for the rainfall indices, I have used another 5 indices. That is RX1 maximum 1-day precipitation, RX5 day, R95P, R99P, and PRCP tot, that means annual total wet day precipitation in millimeter. And from this visual representation, it can be seen that the northern parts show the lower values for the extreme rainfalls, the higher values, and the northern part, the southern part shows the lower values, that means the cold spots. This means that these regions have the lower rainfall comparatively than the northern part of the study area. Now I have made this map using the Moran's spatial clustering tool. And from this map, it is visible that the higher values for the temperature are clustered in the Rajshahi division, and whereas the lower values for extreme temperature indices are clustered somewhere in the northern part here. And as for rainfall indices, all the lower values are clustered in the Rajshahi division, whereas the higher values are clustered in the northern parts, these regions of my study area. This means that these cold spots are vulnerable to low rainfall. Now here is another visual representation of the comparison of drought risk maps and my spatial cluster maps. Here we can see that in a map from Bangladesh Agricultural Research Council, they have published a map of drought risk, and the potential drought prone areas lie in my study areas where the temperature values are extreme temperature indices values are high and precipitation values are low. That means that this Rajshahi division lies in the severe drought prone areas, and the northern part of the study area, that means that Dinajpur and the surrounded areas, lie in the moderate and almost having no drought areas in the map. So what is the outcome of the study? Climate extreme events mostly occur in the hotspots, so it is very important to identify these hotspots for a climate change vulnerable country like Bangladesh. And identifying these hotspots will help the policymakers to implement the climate change adaptation strategies in more efficient ways, which will help mitigate the climate change risk in future days. And now I have the limitation of some limitations of this study, and this is that further quantitative and numerical methods can be used for identifying the temporal changes of such climate indices over in different special locations. And if these temporal changes can be shown with the statistical tools, then better understandings can be made. So that's all about my studies. Thank you.
Thank you for your nice presentation. Now, may I ask the questions of the audience? Thank you. I'm inviting the questions
Can you hear
regarding
me?
the presentation.
Can you hear me?
Yeah. Please go on.
I want to ask a question. If we consider that there is no climate change issue, that means there is the temperature, the global average temperature is not rising. In that case, will these hotspots change the location or change their thresholds?
Sorry, sir, can you ask the question again? I didn't get your question.
Say we have no climate change issue.
Okay.
The global average temperature is not rising. In that situation, your hotspots locations, would the locations be changed or the thresholds be changed?
If there is no climate change issue, then the thresholds, the extreme indices values will not change from the threshold values, because sir, the threshold values are used as a standard. So sir, if there is no climate change, then the standard values, there will be no significant deviation from the standard values of the changing values. So sir, the locations in this, sir, there will be no significant change for the hotspot or such values.
That means your study makes some outcomes which we can call the general climatology of the area. So nowadays, there are in some countries, some people are doing some research in the direction of how we will cope with a very high temperature. May say during 2050 or 2060, 60s, in that decades when the temperature would be risen to by uh, by 1 degrees from now, then we can find some areas in large countries where the present situation is like that type of future situation. So we can show some variety of crops or other things to study how we will cope with that changed situation. So your study maybe is a very simple and general study of climatology over that area. Usually the Rajshahi division is the low temperature, low rainfall and high temperature area in Bangladesh. These are actually extension of the one kind of western desert area. Say if you proceed to western areas like Bihar and Rajasthan, etc., you will come to a desert area. So a desert is extending surrounding its areas, and the effect may come to Bangladesh by some amount, decreasing the rainfall and uh, uh, increasing average or maximum temperature, etc. Thank you.
Any more question? So if there are no questions, so we can go for the next presentation. May I request the next presenter to present the paper ICMCS 28, that is the impacts of radiance data simulation on the simulation of extreme hailstorm events over Bangladesh using WRF model. Thank you.
Hello everyone, myself Jane Saba, MSc student, Department of Meteorology, University of Dhaka. At first, I would like to thank my chair and co-chair of the session to give me this opportunity to present here. My research title is Impact of Radiance Data Assimilation on the Simulation of Extreme Hailstorm Event over Bangladesh using WRF model. Hail is defined as the precipitation in the form of ice that has a diameter at least 5 millimeter. Hailstorm regards as a natural hazard that causes extensive damage to the standing crop building structure and injuries to human beings, leading to death. So effective hailstorm warning should be considered as a boon to the affected society. And Bangladesh experienced its severe thunderstorm with hail between March and May. And the objective of the study to compare and validation of the model output, both control and WFDA of accumulated rainfall, sea level pressure, humidity, dew point temperature, and surface temperature with the observation of the BMD. And second one is to investigate the associative atmospheric condition responsible for the occurrence of hailstorm event over Bangladesh. And the last one is to check and evaluate whether the simulating radiance observation in the weather research forecasting model could improve the amount of hail and location specific forecast of hailstorm. And here is the model configuration and the domain configuration used in this research. And here I used one nested domain, and the outer model resolution is 9 km and the inner resolution is 3 km. And here 37 vertical levels are used in this model, and the microphysics and the cumulus parameter and the radiation parameters are used as the secondary from the analysis of literature review. And the method and data. My whole work can describe by this flowchart. First of all, I select the event based on the secondary data source of national dailies, and according to the event, select the domain. And for the model run, I use GFS data and the ARW post process conducted as the control run. And then also simulate the event, also simulated the event with the AMSO A data, and both output from the ARW post 24-hour simulation visualized with the graphs and compare with the BMD observation data for the model validation. And data used in this research, data used for the event selection of the event are selected based on the secondary source of data as well the national dailies. And for the ARW solver, GFS 0.2 degree analysis of forecast data grid used here, and data for WRF-DA as satellite data, AMSU A radius data used for the simulation. And verification of the model output, Bangladesh Meteorological Department 3 hourly station data used in this research. And here the result and discussion. To compare and validation of the model output, control and WRF-DA conducted, and both are compared with the Bangladesh BMD data, 3 hourly data. This graph represents accumulated rainfall at Moymanshing station and Dhaka station, where at 13 March 2018, Moymanshing station severe hailstorm event occurred, and Dhaka 27th February occurred hail. So in this station are compared with the model output from control and WRF-DA. And it shows the average observation BMD rainfall and temperature both event nearly matched, and it is clear simulated from the WRF-DA is closer than the control run, where the RMSE value is also smaller than the control run. It is shown in the after slide. And in 13th March, both experience simulated relative humidity is comparably low than the observation, but 27th February, WRF-DA results show better than the control run, as the 18 UTC and 0 UTC WRF-DA is totally matched with the observation data from the BMD. In this event, root mean square result is better than the control run, and here is the root mean square of this two event. And in this table, the model simulated environmental parameter are validated BMD observation data, calculating a root mean square for the sake of validation. And from this table, it is clearly shown that from two events, most of the cases, the root mean square is smaller than the control run. So a simulation result is far better than the simulation result. For further study, I use the WRF-DA for analysis of radiance model simulation of hailstorm. And the sea level pressure from the model derived sea level pressure at 1000 hectopascal for 13 March 2018. In this figure, model simulated result shows that there is a center of low pressure with 1008 hectopascal over northwest, and the high pressure is northeastern part of Bangladesh, and there is a trough over there. And again, 27th February 2009 event also, there is a center low pressure over the Shirazganj, and there is a high over the north east part of Bangladesh. And the 30 minutes accumulated rainfall here from the 13th March 2018, here accumulated rainfall more 27 to 30 millimeter over 30 minutes here occurred in the southwestern part of Bangladesh. And the 27th February 2019, there is more than 40 millimeter accumulated rainfall over Nator, Dhaka, and the Shirazganj area. And here is the accumulated hail, where for the 13 March 2018, it is 11 millimeter over the northern part of Bangladesh, Mymensingh, Sherpur, and Rangpur, and relevant area. And the 27th February 2019, here is 18 millimeter rain hail storm counted over the Faridpur, Dhaka, and the Shirazganj area. And the reflectivity from this figure, it is clearly shown that where the reflectivity is more than 50 to 50 dBz, here is further occur hail. So reflectivity is important for the hail. And the convective available potential energy, from this it is clear that where the most of the here represented the 1 hour before the event, and here is high convective available potential energy, and then here there is occurred the hail, and here is not used the actual time of the hailstorm event. And from here it is clear that when the event occurred, the Kep is decreased 100 to 0 joule per kg at that point. And here is the 13 March 2018 some parameter as the vertical profile of reflectivity. From the latitudinal cross section of the vertical profile of the reflectivity, it is clear that the hailstorm event located where the convective unstable atmospheric between 100 to 70 and 700 and the 700 to 30 hectopascal level. And it is clear that it is the unstable condition, and it covered the altitude of the top cloud top. And the vertical velocity of the wind, we know that hailstorm is main cause the updraft and downdraft, and the vertical velocity is the main factor for the hailstorm. And strong rising motion from the 12 to 18 meter per second recorded in the 700 to 200 hectopascal level. And it is clear that there is a strong updraft and downdraft here. And the Graupel mixing ratio and hail mixing ratio also calculated here. And though the Graupel is smaller than the hail mixing ratio, there and smaller than the hail, and it is concentration is more than upper atmosphere. After collision and collision process occurred, and the hail is occurred in this situation. And here also figure show that the 27th February 2019. And here also the strong wind shear is here, and the updraft and downdraft record in the 18 hectopascal to 300 hectopascal level. And Graupel mixing ratio and hail mixing ratio is from the graupel mixing ratio and hail mixing ratio, it is shown that the graupel mixing ratio is smaller than the hail mixing ratio. So it is quite favorable condition to hail growth. The hail location compared between the WFDA and control. And from this figure, 13th March 2018, this figure shows that it is not shown the Sherpur area of the in this map, but WFDA captured this location as well as the 27th February 2009. Dhaka experienced a severe hailstorm. But from this time, this simulated the control run could not capture this location, and it is so from this it is clear that WFDA is better to capture the location rather than the control run. And the comparison of accumulated hail between control and WFDA run. From this analysis, it can conclude that WFDA improved the accuracy of model run as well, that both model can capture peak point of this hail. But from this figure at 13th March 2018, assimilated hail is more intense than the simulated hail. And as well as the 27th February, also assimilated hail is better result than the control run. And in both cases, there is exception at 13 March 2018, 21 UTC, it is opposite than the simulation and assimilation. And simulation is show the higher peak of hail. And here also the 27th February 2019, at 17 UTC, it show the opposite result, as the simulated hail is lower and assimilated hail is show the intense amount of hail. So, and it is so improve the amount of location of hail for both event. It is clear most of the time amount of accumulated hail in millimeter higher than the WFDA to control run of the model. And here is the conclusion. And this research attempt to improve the prediction of both extreme hailstorm event using radiance data simulation and without radiance data simulation, root mean square error have been calculated to find that which model is best forecasting hail in the spatial and time distribution. And results from the radiance data simulation suggest that improvement of the initial condition plays a positive impact of extreme hailstorm event in 24-hour simulation. BMD observation data were compared with both model simulated data and event have been found close to the observation. Therefore, this kind of research can directly help the understand the atmospheric condition more accurately to the forecast well, to reduce damage and property and physical damage. Thanks to all.
Thank you for your presentation. As I've seen that Dr. Mohan raised his hand, please ask a question.
Thank you, sir. The presentation is really nice. It is actually time demanding. There is two things. She assimilate the hail events, also compare with the control run. So what is the gap there? The gap is there is in the many slides there is no comparison with the actual observation. Maybe that is due to the she not able to collect the data from the National Meteorological Department. So that is the one as a specific point. In future, she can improve her presentation by comparing the available observations. In this regard, I think she can seek for the cooperation or coordination from the meteorological department. Thank you very much. Good presentation, Jerin.
Yes, sir.
Thank you. Any more question? So, as there are not any question, so we can go for the last presentation, that is ICMCS 29, prediction of thunderstorms based on atmospheric instability indices over Bangladesh using WRF-ARW model. and it will be presented by Jannatul Firdaus, Department of Meteorology, University of Dhaka, Bangladesh. Thank you.
Good noon, everyone. I am Jannatul Firdaus, MSc student, Department of Meteorology, University of Dhaka. At first, I would like to thank chair and co-chair to give me this opportunity, as well as our honorable chairperson. My presentation title is Prediction of Thunderstorms based on Atmospheric Instability Indices over Bangladesh using WRF ARW model. Here is the outline of my presentation. I will explain in this sequence. Background of the study: thunderstorm is a convective storm which can occur anywhere, but most in the mid-latitude region because of warm moist air. The critical values of different indices is needed for the formation of thunderstorms as well as to make it severe. Objectives of my study: to investigate the predictability of thunderstorm based on instability indices and to verify of thunderstorm forecast as obtained from WRF model. Here is the description of my cases. I have selected 2 cases over Dhaka, which is based on the cloud coverage found from the thermal infrared brightness temperature, which is the outcome of INSAT 3D or satellite image of satellite of India. Here is the indicating case location of my study. In case of model spec, WRF 4.0.3 version has been used in this study, and spatial resolution of my model was 9.3 and 1 kilometer. For physics option, Milband air double moment scheme has been used, and for cumulus scheme, Kane scheme has been used, but for domain 3, no cumulus scheme has been used. Here is the domain of selected cases. I have run the model on this domain, and for model run, 0.25 degree cross 0.25 degree 6 hourly global data has been used, and to verify BMD SQL data, BMD rainfall data, BMD instability indices data, Wiming University sounding data has been used. Methodology. In this study, 2 severe cases have been selected based on SQL data of BMD and newspaper. To investigate meteorological condition, the mean sea level, pressure, temperature, winds at different level, and vertical cross-section of relative humidity have been analyzed from model output. Spatial distribution of indices have been also analyzed. Hourly value of instability indices such that 10 instability indices has been calculated. They are vertical total index, KI index, cross total index, maximum convective available potential energy, maximum convective inhibition energy, bulk resorption number, lifted index, shoulder index, SOET index have been calculated and compared with the area average rainfall value to comprehend the nature of the thunderstorm. At last, root mean square error of indices values have been calculated to show the rate of model error. Here is the results. At first, thermodynamical features. In case of mean sea level pressure, we all know that to form thunderstorm, there is a need of active elongated trough of low pressure over the northeast India and adjoining Bangladesh. In this figure, we are seeing that there is a active elongated pressure in northeast India and adjoining Bangladesh, which is near to 1003 hectopascal. In case of temperature, a warmest temperature is needed to form thunderstorm, and in this case, we are seeing that the temperature is greater than 26 degrees Celsius. In case of low level wind, there is both cases are showing cyclonic rotation, and convergence is not so prominent for case 1, but for case 2, convergence is prominent, better than case 1. In case of upper level wind, we are seeing that on event location, model is giving scatter or no scatter wind and divergence in upper level. Now north-south vertical cross-section of relative humidity. It is found that the vertical profile of relative humidity is reaches up to 200 hectopascal for both cases. And for east-west vertical cross-section, it reaches up to 300 hectopascal for both cases. Now, spatial distribution of for case 1. In case of vertical total index, we are seeing that in northwesterly part, model vertical total index is highest, and over the location it is greater than 26 degrees Celsius. And in case of total index, the value is most in western part, and in case of over location, it is greater than 45 degrees Celsius. And for K index, in western part, value is highest, and in over the location, it is greater than 48 degrees Celsius. In case of gross total index, value is highest over Bangladesh, and over the location it is greater than 22 degrees Celsius. And in case of maximum convective available potential energy, the value was highest at the western part, and it reaches up to 6,500 joule per kg. And over the location is on the time it is greater than 1,500 joule per kg. And in case of maximum convective inhibition energy, the value is always less than 100 joule per kg. In case of bulk resorption number, the value model is giving some missing value on this time. And in case of leap rate index, value is always greater than 10 degrees Celsius, which is not suitable for forming thunderstorm. And in case of shelter index, model is giving 0 to 2 degrees Celsius temperature on that time. And for soil index, it is greater than 300. Now, special distribution of case 2. In these cases, we are seeing the similar thing both cases, but in case of total index, most of the time the value is greater than 53 degrees Celsius. And in case of K index, model is giving value greater than 40 degrees Celsius. And for gross total index, model is giving a value greater than 22 degrees Celsius. In case of M cap value, model is giving value greater than 1,500 joule per kg. And in case of maximum convective inhibition energy, model is giving value less than 100 joule per kg. As well as past cases, in case of bulk resorption number, model is also giving some missing value on this time. In case of leap rate index, model is giving value greater than 10 degrees Celsius. And in case of shelter index, model is giving value 2 to 5 degrees Celsius. And in case of soil index, model is giving value greater than 350. Now, instability incident with rainfall value. In this time, I have calculated area average rainfall value and described with the model highest value. For vertical total index, we are seeing that in case of one, the rainfall is highest at 13 UTC, but vertical total index value was highest at 11 UTC. In case of total index, model is giving highest value at 9 UTC, and the rainfall value is highest at 13 UTC. In case of KI index, model is giving highest value at 10 UTC. In case of gross total index, model is giving highest value at 6 UTC. That means 6 hours before of the storm. And in case of M cap value, model is giving highest value at 6 UTC. That means 6 hours before of the event. And in case of M kind, on that day, from 4 UTC to 10 UTC, model is giving the lowest M kind value, and that is 0.1 joule per kg. Some value is missing for bulk resorption number, but highest value is at 6 UTC. In case of lifted index, model is giving lowest lifted index value, which is valid for 3 UTC, and it is some closer to 10 degrees Celsius. And for shelter index, model is giving lowest value at 4 UTC, which is near to 0 degrees Celsius. And for soil index, it is zigzag type and decreasing and after increasing, but highest value is at 12 UTC. Here is for case 2. Vertical total index was highest at 10 UTC, but rainfall value was highest at 14 UTC. For total index was highest at 10 UTC, and for KI index, model drive value was highest at 12 UTC. For cross total index, value was highest at 11 UTC, and for MCAP value was highest at 4 UTC. That means 8 hours before of the event. And for MKIN value, from 3 UTC to 11 UTC, model is giving the lowest value, and for bulk resorption number, at 4 UTC, model is giving the highest value. For lifted index, at 6 UTC, model is giving the lowest lifted index value, that is near to minus 30 degrees Celsius. And in case of shelter index, model is giving lowest value at 6 UTC near to 0 degrees Celsius. And for soil index, model is giving highest value at 10 UTC. Here is the synthesized results of my indices value. Highest VTI value was at 11 UTC, and the value is 29.94 degrees Celsius for case 1. And for case 2, 9 UTC, model is giving highest value, and the value is 31.81 degrees Celsius. That means 1 hour 15 minutes before, the model is giving highest value before event. And for case 2, 3 hour 22 minutes before, model is giving the highest value. And for In case of total index, at 7 UTC, model is giving the highest value, which is 49.83 degrees Celsius, and for case 2, it is 10 UTC, and the value is 57.42 degrees Celsius. For case 1, 5 or 50 minutes before storm, and for case 2, 2 or 22 minutes before, model is giving the highest value. And for KI index, the highest value is at 11 UTC, and the value is 41.68 degrees Celsius, and for case 2, the same time 11 UTC, and the value is 42.62 degrees Celsius. That means on or 50 minutes before of storm for case 1, and for case 2, it is on or 22 minutes before of the event. And for in case of gross total index, at 7 UTC, model is giving the highest value, and that is 22.74 degrees Celsius, and for case 2, it is 10 UTC, and the value is 26.43 degrees Celsius. In case 1, 5 or 50 minutes ago, model is giving the highest value, and for case 2, 2 or 22 minutes before. In case of maximum convective available potential energy, the highest value is 3,345.95 joule per kg, which is valid for 6 UTC, and for case 2, it is 3,090.68 joule per kg, which is valid for 4 UTC. That means 6 or 50 minutes before of first event, and in case of case 2, it is 8 or 22 minutes before, model is giving the highest MCAP value. Lowest MCAP value is 0.1 joule per kg, which is valid for 5 to 11 UTC, and for case 2, it is 0.1 joule per kg, which is valid for 3 to 10 UTC. Highest VRM value was for case on is 105.98 meter square per second square, which is valid for 6 UTC, and for case 2 at 5 UTC, the value is 147 meter square per second square. Lowest LI value was valid for 2 UTC, and the value is 7.32 degrees Celsius, and for case 2, the lowest value is at 6 UTC, and the value is minus 34.43 degrees Celsius. And for SI index, the lowest value is 0.76 degrees Celsius, which is valid for 5 UTC, and for case 2, it is 5 UTC, and the value is 1.03 degrees Celsius. And highest SOIT index value is 366.204, which is valid for 12 UTC, that means on or before of the event, and for case 2, it is 496.12, that is valid for 9 UTC. Highest dissipating of the irregular rainfall was 45.602 millimeter, which is valid for 13 UTC, that means 10 minutes after storm, and for case 2, it is 1 hour 1.5 hour after storm, and the value is 130.252 millimeter. Here is the rate of error statistics based on 00 UTC of BMD data. In case of vertical total index, for case 1, the rate of error is 0.37%, and in case of case 2, the rate of error is 0.83%. In case of total index, rate of error is 0.59%, and for case 2, it is 1.76%. For KI index, rate of error is 1.83%, and case 2, 5.05%. For cross total index, it is 2.02%. For case 2, 3.1%, and for CAPE, 6.32%, and for case 1, and for case 2, it is 17.43%. For KINE, it is 28.69% for case 1 and 9.93% for case 2. For bulk resource number, 10% of rate of error, which is for case 1, and for case 2, it is 14.27%. For lifted index, it is 10%, and for case 1, and for case 2, it is 3.23%. For shoulder index, 24.05% for case 1 and 48.6% for case 2. And sweat index, 6.48% for case 1 and 2.91% for case 2. Discussion and conclusion. From this study, we found that to form thunderstorm, low pressure area is must with high temperature, that means greater than 26 degrees Celsius, as well as 80% of moisture availability. Indices value increases sharply 5 to 6 hours before occurring of thunderstorm. MCAP is giving more predictable and reliable result in forecasting of thunderstorm. This study found that the model gives less rate of error for case 1. That is case 1, I have explained later past. More number of thunderstorm cases have to run with ensembles as well as several types of physics combination to get better results over any region. Thank you all. If any question or further suggestion.
Thank you for your presentation. May I invite questions, if there is any?
Yeah, I want to ask a question.
Please go ahead.
Orography has got any role to play in the modification of uh, this stability indexes? Orography.
Again, please, sir. I did not hear you.
Orography has got any role to play in modifying this stability indices?
No, sir.
Yeah.
No, sir.
Anybody can supplement her in the department? Or Dr. Prabhat, you can explain the thing.
I think orography has got a very important role to play in.
Sir, I can clear the things. Orography has a great effect on the indices, but in her study, orographical effect was not studied, was not considered.
Okay.
But I think later on we can assign another student to study on that matter. Thank you, sir.
Well, I have something to say about the orographic effect. Orographic effect is very important for the convection to occur, you know. But this place, Dhaka city, was away from the hill areas. So, yeah, here the orographic effect is not there probably because hills are much away from here. So that's my supplement.
Any question?
Can I say something?
Sure.
I saw in her presentation that in almost all cases, she found Li and Si positive values,
Yes, sir.
maybe 7. But this should not be like that. There might be some problem with your experiments. And another thing is that the bulk Richardson number is not needed for our region because of this index is applicable for regions where Rossby number is very low. So some sort of combination of indices should be chosen before designing experiments with this type of events. I think Li should be negative on our area for any thunderstorm. There might be some problem with your experiment. Please recheck and please talk to other experimenters or your
Yes, sir. I will
teachers.
consider this later on my future work. Thank you, sir.
So, any more question? As there are no more questions, so we can conclude the session. Before that, I would like to request Dr. Sadiqul Alam, as you were one of the co-author of the paper. So it should be the things would be corrected earlier. Thank you very much. So before concluding, I would like to request our co-chair, Dr. Mohammad Nazmul, to provide his concluding remarks.
Okay, sir. In this session, there are 4 papers, and first papers on dynamic amplification of jumping rate of lightning prior to tornadogenesis. The presentation is given by Professor Pramod Kumar. Actually, he is very well known professor and researcher in this area. And during my stay in SARC Meteorological Department, we know him. Actually, he has a book, Hailstorm and Hydraulic Machines, that is a very popular and well explained book and very favorite book to the meteorologist. And he explained and showed that rate of lightning jump just prior to the tornado genesis, and after tornado, actually, if it is a ground to ground lightning, then it is reduces. So he explained many things nicely in his presentations. And our second presenter, scheduled presenter, Tanjina Akram, was absent. And in this schedule, another presentation, hotspots on extreme climate events in the northwestern parts of Bangladesh, was given by the Tasnim Sultana. He's a student of MSc first year. And just few days ago, he take this study and carried out and presented here. It is not still in full format. He is ongoing research, and he will maybe it will take for his future research and will enrich the research activities. But his presentation and result was quite good, and we like to appreciate her to present this paper in such international conference. And our third presenter, Jerin Sawa, she presented impacts on radiance data simulation on the simulation of extreme hailstorm events over Bangladesh using WRF model. They simulated two cases with 3D wave data simulation. She used radiance data in the on the simulation, and she is our master's student, final year student. Actually, she took his thesis just before the COVID-19 situation, and during COVID-19 situation, she carried out this research in collaboration with Bangladesh Meteorological Department and and Shuras, India. So her works was very excellent, and result, especially 13th March 2018 cases, was she found very good result, and I think we should appreciate her to carry out this research. And four presenter, Janatul Firdaus. She presented the paper on prediction of thunderstorm based on atmospheric indices, instability indices over Bangladesh using WRF ARW model. She tried to forecast the thunderstorm based on some indices which available used by the meteorological community. Actually, she used the WRF model. So all indices are not simulated properly by the model. So model also used some data at different sources. So based on the initial conditions data, it shows all results are not our expected. And if data simulation is done by with this simulation, then result will be good for us. So she also done his thesis during pandemic situation, and she did very excellent work. So I like to congratulate her also in this. So these four papers, all authors are congratulate for this for the presentations. This is all. So in this stage, I like to conclude, and I give the floor to our honorable chair of the session to conclude the session. Thank you.
Thank you, Dr. Mohammad Nazmullah Hassan. Thanks for your concluding remarks. As I would like to express my gratitude and honor to be the chair of the session, as our Honorable Director, Bangladesh Meteorological Department is sick. So on behalf of him, I chaired the session. As you know that in Bangladesh, only few science studies have been conducted on lightning. This revealed that those studies reveal that the number of lightning incidents are high in Bangladesh. Considering the massive death toll due to lightning, in 2016, the government of Bangladesh has declared it as a natural disaster. In 2020, according to the information of Dhaka Tribune, at least 79 people died due to thunderstorm from 1st January to 30th April. In March and April alone, 70 people died. Of them, 40 people died in crop fields. As a practitioner or working in the Department of Agricultural Extension, you know that in 30 years ago, only 2 rice crops are produced here, like pre-monsoon and monsoon, that is Aush and Amon rice. And for last 30 years, the Boro cultivation started. It is the winter rice, and the harvesting time is April, last week of April, and second or third week of May. It is depends on the location of the crop field in the country. So, and the lightning occurs in the harvesting period. And as you know that our paddy fields are vast, empty, exposed, meaning that we have no place to take a shelter if lightning strikes. And this is causing difficulty to harvest the crop in our crop field. And victims of lightning are mostly farmers. And this makes sense because lightning strikes the highest object first, as Boro rice harvesting period around the end of April and beginning of May. So from today's technical session, the core presentation was done, especially on lightning and the hailstorm incidences. So I'd like to request everyone who are working in research field or educational field, we need more research in this, in the early warning and forecasting of the lightning and also the hailstorm. Maybe hailstorm is a little bit difficult, but I think as I came to know that different organizations like Art Network, uh, they're producing early warning and forecasting 40 minutes earlier with the lead time of 40 minutes around 20 kilometers resolution. So this type of things, after conducting the research on lightning, and it has to go to operational meteorology, and in terms of early warning and forecasting, that we can, as you know, that agricultural department is the largest department, second largest department next to health department, and we have the organizational structure in the in block level, that is sub union level. So if we get the information earlier, the forecast and also the early warning, that it will be easier for us to disseminate our farmers or inform the farmers. And according to our World Bank funded project, Bangladesh Agro-Meteorological Information System Development Project, that is BAMIS Component C of Bangladesh Weather and Climate Services Regional Project. We are working in that field, and we have database of 30,000 lead farmers, and also around all over the country from 15,000 groups. And also we have 12,000 sub-assistant agriculture officers who are working in the field. And also we have district level, upazila level, and also region level structures. So If the science is developed and more study could be conducted in lightning and also in hailstorm, tornado. So if we have a lead time to disseminate this kind of early warning and forecasting to the farmers, it would create a big impact in our agriculture sector. For this remarks, I thank you everybody to be present and also let us know the development of lightning and hailstorm and tornado. Different research work are conducting. So we welcome everybody. And also, I would like to request you all again to conduct more research in this field. Thank you, everybody.
On behalf of the organizing committee of this conference and Department of Meteorology, I would like to thank Honorable Chair and Co-Chair for conducting the session and all the presenters for their wonderful presentation. I would also like to thank all the audience for being present in this session. The next session of this conference will be start at 14:30 in Bangladesh Standard Time. So all are invited to join the session. Thank you all.
Thank you, everybody.